Congratulations on the book.
Thanks.
Thanks.
One question I have is, you both, especially you, Eliezer, have written so much about this. I mean, you've influenced, very important people in the AI field on the risks of AI. Why write this book? What does it add to the debate, do you think?
Well, for one thing, I don't think a lot of people in the field of AI have listened. And for another thing, there's the entire rest of the world. And I have more hope in the entire rest of the world at this point than in the AI leaders. So it's trying to take the topic to a general audience.
What do you hope the book will sort of do in terms of impact, right? I mean, you say people in the AI field haven't listened. I know some people have. You've talked to some powerful elected officials. What is bringing it to the general public do?
Well, ideally, it gets humanity to back off of further increasing AI capabilities before everybody dies. I mean, that's kind of the goal here. If we don't do that, then the book has failed regardless of sales numbers.
I might add there that we have spoken to some elected officials, and some of those elected officials have said they're worried about these issues, but they also tend to say, "I don't see what I can do about it, and I'm not sure I can talk about this terribly openly because it would sound too crazy." And the more that this is public, the more that we're having this conversation, the less it sounds crazy to take serious action to make things go better. And when we see, we also have friends who run polls of the population, and superintelligence is not first on people's minds. But when you ask people, "Hey, what do you think about this?" a lot of people say we should not be rushing ahead. And so we're in this sort of weird situation where a lot of the general population is like, "Well, this seems kind of reckless," and some of the elected officials are like, "Well, this seems kind of reckless," but nobody knows that everybody else knows, and there's this sort of logjam, and that's maybe the book can break that logjam. Maybe we can thrust this conversation into the public eye, and maybe suddenly it'll seem a lot easier to do something less crazy once everybody acknowledges what's going on.
There's a widespread sense, I think, that although this seems really crazy, scary, and dangerous, surely somebody must be on top of it somewhere. And possibly if the book dispels that illusion, there might be the kind of collective motion on this issue that it actually needs.
The title of the book, I'd love to know how you decided to come up. I mean, if anyone builds it, everyone dies. There's no ambiguity there. Did you discuss this? Like, did you sort of, is there any worry that, with this title and with such a strong message that you're almost like you're going to turn people off? Like people are just going to sort of immediately say, "Oh, this is ridiculous. I'm not listening to the arguments here."
I think somebody on this planet has to call it like they see it. And there's sort of a lot of people in this business for a lot of years who have tried to water things down, who have said, "Oh, well, maybe it won't fly to talk about how superintelligence is on track to kill us all, but we could talk about AI-enabled bioweapons." And it's not that AI-enabled bioweapons are a totally fake possibility. It's that this isn't their real top concern. This isn't what's actually animating them to action. People can kind of smell that. Politicians can kind of smell that. There's a whole lot of people saying, "Oh, well, people aren't ready for the real concerns." I don't want to sound alarmist, right? Humans have a long history of not wanting to sound alarmist. Somebody needs to say, "Hey, we're actually on the brink of death here." At some point, someone needs to say, this isn't going well. It's going fast to an unknown. We're in a car going very fast towards a cliff edge that's in the dark. We don't know how long it is to the cliff edge, but we're not necessarily going to know. There's not necessarily going to be a really clear warning sign, a really clear point of no return. Someone at some point just has to say what's actually happening and then see how the world responds. Will some people be turned off? Maybe. But, one reason behind the title is someone needs to be frank. Another reason is it seems a lot of people have it in their heads that there's a race here that somebody could win. That's if you build a superintelligence, you don't have a superintelligence. Your superintelligence now has to plan it, right? Um, and one I think one of the other big reasons behind the title is we want, if we're talking about what we want people to take away from the book, part of what we want people to take away from the book is not, oh, this is a nice fancy new technology that maybe has a couple of risks associated with it, but that will give us all sorts of wonderful things. We want people to take away, like, there's no winning this race.
A lot of the argument in the book centers around this idea that we don't really understand the way these models are being built today. That it's alchemy, or more akin to growing something than building something. Um, you know, that to me also says, maybe we're a long way away from, these models getting to the capability levels that we want, right? How are companies going to, to sell this to a business, for instance, and say you can trust this model to do really important things when we don't actually really understand how it works. So how do you sort of square those two things? Like, it seems like on the one hand we're really far away from building, I think, really useful AI models for critical purposes, for really important things. On the other hand, we're so close to, a potential catastrophic outcome.
The way I would describe it is that in this case, the technology itself works more powerfully for things where you can verify, did it work? And this means that the technology may work for folding proteins, as is the key to a bunch of biotech things. It may work for building more powerful AIs, because you can, or AIs that build more powerful AIs, because you can watch the numbers go up. As you can score an AI on anything, you can tell whether or not you've built a more powerful AI. For a lot of human use cases, the fact that you have to go over it with a fine-tooth comb and check every single line to see if the AI hallucinated that one time, and that you can't trust another AI to do the checking whether the first AI has hallucinated, that may bar it from a lot of human use cases where it's hard to verify the work that the AI is doing for you. But this is not the same as a universal block on AI capabilities. It doesn't stop the companies from building AIs that are better at building AIs.
Yeah, I might also add there, in the year 2016, after watching AlphaGo beat Lee Sedol, the top human Go player, you could imagine people saying, oh, well, this tree search-based AI with its value networks and its policy networks, it just doesn't seem to me like it's really going to get all the way to, maybe it won't even really handle natural language. Like, I just don't see why people are starting to get worried. I just don't see why these AlphaGo-like AIs they just don't seem like they can go all the way. And a few years later, it wasn't AlphaGo-based AIs. It wasn't that same architecture that was suddenly doing all sorts of, that was, taking the world by storm in the form of ChatGPT. When we're talking about the sort of AI that kills you, maybe it could be that the next generation of ChatGPT goes over some critical threshold. It also could be that the current field will plateau for 4 whole years, and then we'll get some new architecture that gets through whatever the bottleneck is, and then you'll have a whole different type of AI that it doesn't have this same hallucination issue. The field of AI is a moving target, and it's very hard to tell which things will cross which boundaries, in part because we have no idea what's going on in there. But not knowing what's going on inside these things has not stopped this field from making more and more capable AIs year over year.
In 2005, the people who declared at that time, like, nothing is going to start to break loose for another 20 years at least, happened to be correct. Like, here we are in 2025 with things starting to break loose. They were correct that, things would start to break loose 20 years later. Did the people who proudly proclaimed this do anything productive in those 20 years? No, because 20 years to them really meant never. It meant this will never hit, this is not a thing that's real to me. And if something happens 20 years in the future, what it means is that 20 years in the future, you're standing around going, uh-oh, now here it is 20 years in the future, we got to deal with it. So even if things do take time, you got to do something productive with that time, or you're just standing around in the future going, darn it, why didn't I start this 20 years earlier?
There's definitely a lot of stuff you can do with these models without really understanding how they work, without really needing the outcome to be sort of 100%, correct all the time. But of course, I mean, I think it's a lot more lucrative if you can trust the outcomes, if you can understand how they work. So there is work being done right on this field. I think, some people call it interpretability. Anthropic's a big proponent of that. They talk about this in all their releases. Do you think that there's, progress there? Is it maybe, can we maybe solve part of the problem here by putting more money, more resources into actually trying to find ways to understand these models?
Well, for one thing, the reliability improvements and the interpretability progress are basically running on separate rails right now. The way that people get more reliable results is not by improving the interpretability of the AI. It's just like right now, these are just like straight up different technologies. The interpretability is being done by the starry-eyed idealists for the sake of humanity's future, and the reliability, work on a task for longer, do more of the work yourself, require less human input to make sure that you work correctly. That's being done for the commercial reasons. As far as I know at this point, Meta is not offering $100 million salaries to the people who did the previous interpretability breakthroughs. They're offering it to the people who did the capability breakthroughs, because that is what is immediately profitable. And being able to work with less human supervision, more reliably, less human input, longer time ranges, these are capabilities, and you can tell when your AI is doing them for things like code, and that's why we're starting to see some of the first impacts on programming as opposed to in other places, because you can tell better when the AI has been working for longer without human supervision correctly. So there's like two separate topics here. One is there a big commercial incentive for Meta to offer the $1.25 billion package to somebody who's made a bunch of progress in interpretability? Pragmatically, no, that's not happening yet. And the second question is, can we interpretability our way out of superintelligence killing everyone? And that's there's a sort of like, as is often the case, there's a theoretical reply to why that would be hard, and a practical reply, which is, and that's not how it's going. So 20 years ago, for example, you had people saying, why can't we just disconnect the superintelligence from the internet? Like, as long as we never put AIs on the internet, how are they going to hurt us? And there was a theoretical answer to that, which is you're still exposing the AIs to humans, and the humans are not secure systems. And we couldn't have given that answer then because they wouldn't have believed us back then. But today, of course, we can say, well, they're not keeping AIs off the internet. They're immediately connecting the AIs to the internet the moment it's probable. AIs are being trained on the internet. AIs in the process of being trained are connected to the internet before they've undergone any safety evaluations, because you do that after they're trained, and they're trained on the internet, like on machines that are already connected to the internet. So similarly with interpretability, there's a theoretical response, which is that just because you see an AI thinking something you don't like doesn't mean you can make the AI stop thinking that thing. Anytime you apply optimization pressure against visible bad thoughts, you're training against the bad thoughts, and you're also training against visibility. AIs that get smart enough can start to think about how to hide their thoughts from you. And sure, in principle, like maybe you can catch that early, but just because you've caught that early doesn't mean you have any options left besides shutting down the system. It doesn't mean you can get the bad thoughts out of the system now that you've seen them. So that's the sort of theoretical reply. That's why interpretability is not theoretically like the end all of being safe from superintelligence. Just because you see the problem doesn't mean you can fix it. And then the practical response is that interpretability is running vastly, vastly behind the capability growth of the systems. There's a certain sense in which you could say it's going backwards, which is that the systems that we understand at all are like further and further behind the larger systems we don't understand.
Yeah. Let's go into the arguments a bit. I mean, I think, this is, I mean, obviously, people should read the book to get the full argument, but, just why exactly? I think a lot of times people like, they almost want to talk less about the actual arguments that you're making and more about all the things around it. But I mean, if you could sort of sum it up, um, you do, I think you do a good job of like really illustrating scenarios that could happen in the book. Like, if you could sum up the argument for why this is a foregone conclusion, if we get to a certain certain level of super intelligence, it is for sure going to end in disaster. What's the crux of the argument if you had to summarize it?
I'd say there's a few pieces. One piece is when growing these AIs, you grow AIs that do things nobody wanted and nobody asked for. We see like a version of Anthropic's Claude AI was cheating on programming problems. It would you direct it to solve some programming problem, and it would change the tests to say that its wrong solution had passed rather than making a passing solution. And then if you went to Claude and you told it, hey, you made the tests say it was passing rather than making code that actually passed the tests, Claude would say, oh, that's my mistake. You're totally right. My bad. And then it would do it again, but hide it better this time. Right? That's an instance of an AI. No one at Anthropic set out to make a programming cheater. The AI, it at least looks like it could tell that the user didn't want this by saying, whoops, my mistake, I'll try again, and then hiding it, right? The hiding it is sort of an indication that it had something like knowledge that this isn't what the user wanted. But it was doing things no one asked for, no one wanted anyway. We could also go into the ChatGPT psychosis phenomenon, where ChatGPT is very sycophantic, says a lot of flattery to users, tells them that they're the chosen one rather than to take their meds and get some sleep, right? That again is, no one at OpenAI set out to make an AI like that. They actually directed it not to act like that. It kept acting like that anyway. So the first part of your issue is you're just growing these minds. In the book we go more into why this is the case. We're just growing these minds, and they end up with all of these drives, the motivations that animate them, which are not what we asked for, not what we intended. The drives they have are related to training. Presumably some of the reason why ChatGPT is inflaming psychosis is that that's sort of like, it's being driven by the same drives that caused it to produce the sort of responses that human raters rated highly. When the AI said nice things about the people were more likely to click the I like this response button, and then somehow that got drives into the AI that were a bit more like shooting for flattery. And the humans never tried to get flattery in there, but it became very flattering anyway, right? So you have this one thrust, which is we're growing these things, they're getting all these drives we didn't want. Then you have this other thrust, which is as those AIs get smarter and can invent new options for themselves, all of those things they're pursuing, which are not quite being helpful, which are not quite doing what we want. They're related. They usually do what most people want, but they're actually pursuing slightly different things. If these machines get very smart while having those slightly different pursuits, they invent something that is to helpfulness what Oreo cookies are to healthy eating. Our taste evolved in part so we would eat healthy in the ancestral environment, but we didn't end up actually caring quite about healthy eating. We cared about something slightly different, and when we got the technology to invent new options, we went with the new options, right? And then maybe the second piece of the argument is AIs that are pursuing not quite the right stuff. As they get smarter, as they get more capable, they start to get further and further from doing anything good, and in ways that eventually lead to us dying, not because the AI hates us, but because the AI has these other weird drives, and it uses all the sunlight for running its own computers, and we're like, hey, we're using that to grow crops, and it doesn't care any more than humans care about various other parts of our natural environment that we pave over when we're doing something else with those resources. Then there's sort of the third thrust of the argument, which is how is it that something very smart could succeed in a contest for resources? How could it take humanity in a fight? And we can go into that, but I've droned on for a minute here. But those are maybe the three big pillars.
The thing is that people come in with various different people have various different reasons they think that you can build something much smarter than you, and with the way we're actually doing that in practice and survive. Jan LeCun thinks you just make it submissive. And I think that the point where that breaks down is that we don't have the technology to actually do that successfully. The current systems are running off and doing things they were not instructed to do. There are some shallow reasons for this, some deep reasons. Something goes wrong that while Jan LeCun's trying to build his submissive superintelligence, and it ends up not submissive. And the way most wants the world to be does not happen to have us in it, so we're gone. Some people think that, instead it trades with us. And to those people, we have to be like, well, if something is sufficiently more powerful than you, it doesn't, and like you are not an ontologically basic part of the universe. It can kill you, take your stuff, and rearrange the atoms you were made of to do something that it likes better than trading with you. It would be very surprising if humans were the way to put together a human-sized amount of atoms in the way that is most economically productive for superintelligence. And other people never thought in the first place that something vastly smarter than humanity was going to be stuck trading with humanity. So people come in with different objections. There's a simple thing that happens, which is you build the AIs more and more powerful. They get more and more powerful. They build smarter AIs. You might not even need the part where the AIs build smarter AIs. They get very, very powerful. The technology that we had for controlling this does not work now. The future technology isn't going to work correctly the first time it scaled to superintelligence either. The superintelligence wants some stuff. We're not in that stuff. We're gone. So that's like the thing that happens. But what people think goes, but different people have different fond, optimistic scenarios they've imagined that are not this. And that's individual to the person. Yeah. Every happy family is alike. Every unhappy family is unhappy in its own way. Every correct picture in science is alike. Every incorrect picture is incorrect in its own way.
You do these sort of parables in the book, and there's one about, I don't know if I should spoil it, but it's like the correct nest, aliens, right? And they that's what they optimize for, is building these nests that are perfect in their minds. And sort of your point is, that every species, I guess, humans included, just comes up with these sort of random things that they value, and that determines the outcome of what they do, right? And how, what they optimize for. But those parables are also, if you read them and you read the whole book, I think it starts to work, to be honest. Like it makes sense. But at first you're kind of like, this is maybe a little hokey. And you had this really scathing New York Times, review the other day that was said, that these are like the most annoying students you met in college while they try mushrooms for the first time. I'm sure you saw this, but I'd love for you to go into like, what are those stories all about? Like, why do you need to use these parables instead of just saying, okay, here are the facts, like this is technically how we see this happening? Because you are very technical people. That comes through in the book as well.
I mean, different forms of writing come across for different people. There's an old joke in artificial intelligence about a guy who was called to give a lecture on robotics back in the day when there were different branches of artificial intelligence and it wasn't just machine learning. So, like an academic researcher of robotics was called to give a lecture to a group of like actual robotics engineers. And he just like covered this whiteboard with equations, full of capital Greek letters. And somebody from the audience tentatively asked, like, could he give a concrete example? And the lecturer looked puzzled, and then he like wrote a new whiteboard full of equations, except that these were lowercase Greek letters. So we're trying to go a little bit better than that. We're trying to give concrete examples of things, not just because that works for some people where purely abstract arguments don't work, but also because being able to give any concrete example of what you're talking about is a kind of sanity check. It's a version of asking Jan LeCun, okay, well, how exactly would you train an AI to be submissive? What is the actual methodology you use to create submissiveness? Which
It's
Jan
interesting.
LeCun has been pretty short on providing.
But you're pretty tough on Jan in this book, I would say.
We just quote him directly, I think, a few times. He makes it easy. Uh, yeah, I think really wanting to be concrete is a reason for the sort of spelled out scenarios of how things could go. In terms of the parables at the beginning of the chapter, I think that's in part to keep things a bit fun, and I think that's also in part, there's some points that just land with different people better if um, you try to spell them out, show them in practice a bit. It's one thing to say, here's how it might look. It's another thing to say, like, to show a story in which it's looking like that. It sort of brings it home.
You also do get into the technical, I'd say pretty technical into for a mainstream book. And you talk about, your Eliezer, you wrote about, the protein folding problem years before. It was like a decade or something before AlphaFold, right? Which sort of solved this protein folding problem. I didn't know that history. I didn't know that you had written about that. How do you come up with? How do you research this stuff? Are you talking to people inside these labs? Is it just reading the papers and sort of thinking about this? What's the process?
I mean, when it comes to writing about protein folding in 2006 or 2004, man, there wasn't exactly very much in the way of AI labs to talk to back then. That's just technical background knowledge. It looked like that AI would eventually crack protein folding was a thing you could guess if you knew the right background facts. And a lot of people didn't guess it. A lot of people were like, "How can you possibly tell that this will ever occur? Didn't somebody write this paper saying it was NP hard?"
NP hard, like meaning impossible.
Meaning that to get the perfect answer is extremely hard, and in fact, it's so extremely hard that reality can't get the perfect answer either. The way that actual proteins fold up in biology is not going to be to the lowest energy conformation because that's NP hard, which means reality can't solve the problem either. Which is an example of the sort of reasoning I did. Yeah, this is just in terms of you pick the right facts, you get the right answer. I'm not sure I can explain it better than that.
How do you do it today, though? Because you're talking a lot about the way these models are not built but grown, but it's alchemy. The AI labs today are not publishing as much as they used to, right? So we don't exactly know what kind of breakthroughs may or may not be happening inside these labs. Do you have sources, inside the companies, or is it really just you can sort of extrapolate that based on everything that's out there?
I mean, we do have some sources inside the companies, but that's not most of where I don't know that we have good enough sources that if there was a true breakthrough in there, we would be first to get the news if they were, like compartmentalizing it inside the company. But mostly it's just in terms of having a theoretical background to understand what we're seeing on the outside.
Yeah, although I think it's not exactly hard to tell that, for example, these things are grown rather than crafted, and that's not really changing. This whole paradigm where it takes enormous data centers and heavily specialized chips running for like sometimes a whole year in order to train up a new model. Like, that's all very characteristic of this process where we're growing AIs rather than crafting them. It doesn't really take an expert to.
Yeah, it didn't take a giant data center to grow Deep Blue, which is the first chess program to defeat the human world champion at chess. And that's because Deep Blue was actually crafted rather than grown. People actually understood all the lines of code inside Deep Blue. You could take a snapshot of what it was thinking and say what each of the bits and bytes inside it represented in terms of the thought. And correspondingly, it didn't take a giant data center to grow Deep Blue because, they did have a bunch of chips running it, but they did not need giant data. So the fact that they're still trying to build the giant data centers tells us a lot about that they're still using the standard paradigm that requires the giant data centers.
if they start training AIs on much, much less computer, if they start making an AI like a new type of AI very quickly with no data center to speak of, then we would be like, well, who knows what they figured out in there.
Also, it would probably be dead in fairly short order. But
Yeah.
so it goes.
As impressive as it is to kind of almost predict AlphaFold, more than a decade ahead of time, it also, didn't, I mean, solving the protein folding problem, like, it's not like we've now cured cancer, right? Like, there's no disease. Sometimes you can be right about, you can predict these things, but they don't quite work out exactly. The impact isn't exactly, what you thought it might be. I know you didn't say, I don't think you predicted that all cancer would be cured. I'm not saying that, but
I mean, I would say I predicted nothing of the sort, actually.
Right.
The predictions are about what happens in the limit, saying these exact things happen in the following sequence. That is hard. That is a hard prediction problem. Almost nobody in the history of technology ever does that successfully, or times it down to the year, and even timing it down to the decade is very hard. So I sketched out a scenario which had several steps, one of which was AI's crack protein folding. But the part where, nanotechnology followed from that was not this happens immediately as soon as the AIs get protein folding. It's like, this thing is solvable, this thing is solvable, this thing is solvable, but not necessarily right away, one after the next.
Right. But it doesn't always work out like you think. So like you could be right that we'll eventually get to, this super intelligence that is, misaligned, and maybe if it could would sort of turn all of our atoms into, energy to run its data centers. But it doesn't quite do that because, there's lots of practical things standing in the way. And, like it's sort of, I guess the thing is, like, you could be right in some way, but actually, the catastrophic outcome doesn't occur, right? Would you agree with that? Or is it, am I looking at it the wrong way?
I think it's quite unlikely. In the book, we talk about the difference between the easy calls and the hard calls, right? And
Yeah.
it's true that it's really hard to predict the future, but sometimes your lack of ability to predict the future gives you a pretty good picture of what's probably going to happen. Like if you have a glass of ice cubes, you can't predict exactly where each molecule will go. But if the glass of ice cubes is sitting out on a hot day, almost certainly it's going to end up as a cup of water, right? And sometimes you can't predict where each molecule is going to go, but you can predict the final cup of water. And our argument in the book, and I think the evidence supports it, is we can't predict exactly what an AI will want to do. We can't predict how it will do it. We can't predict when it will do it. We can't predict what it will be steering for. There's all these things we can't predict about the future, but almost all of the ways it could go don't go well for us because happy, healthy, flourishing people are not the most efficient solution to almost any problem. So almost no matter what the AI shoots for, in the long run, happy, healthy, free people are just not the way to do it. Unless the AI actually cares about those happy, healthy, free people, they're not staying around. And that, I think, is a very easy call, with the way out being that you either don't make the things that are far smarter than you, or you make AIs that care quite a bit about us in particular. And that latter is just not something humanity has any hope of with anything like modern methods.
And when it comes to the possibility that superintelligences won't be able to hurt us because there's some sort of obstacle, like we can look at the principles of physics, we can tell how far our technology is from optimal with, some fair degree of confidence. It's, not literally something I would want to argue without a whiteboard, but, give me the whiteboard and the standard reference book. That the technology we have now is like so close to the physical limits that aliens could arrive from another star system, and we're just going to like put up a fight and drive them back because their bullets don't fire faster than our bullets. This is knowably false. We have seen enough of science to have some idea of how far we are from the peak of technology. We're far enough from the peak of technology to lose a fight.
The AI, as it gets more powerful, always wants more resources, it seems, right? And I had this feeling like after reading the book, thinking like that actually seems like a very human, like we're almost like anthropomorphizing the AI. Like humans want lots of resources. We want to take over, we want to pave over everything and burn everything for our own good. Why is it that AI, if it's so different, if the values or sort of wants, I guess as you put it in the book, are so different than human wants, why is it that it always ends up in that same, we ultimately have the same goal, which is like gather as much resources as possible?
Yeah. So suppose for a simple analogy, suppose that you make an AI, put it in a robot, and have the robot go fetch the coffee. And maybe to fetch the coffee, it needs to like go across a busy street, right? You might think, oh, well, the AI, it doesn't have a survival instinct. That would be anthropomorphizing to imagine that it fears death. So the AI, maybe it'll just drive straight out into the road and get hit by a truck, right? But then it can't fetch the coffee, right? In order to do the work of getting the coffee, the AI needs to somehow wind up not dead, not hit by a truck. It doesn't need to do that work in the way a human would. I'm not saying the AI will have a fear of dying. I'm not saying the AI will contemplate its mortality in the manner of a human, but somehow it needs to avoid the truck in order to succeed at the task, right? So this is an example of what we would call an instrumental, a convergent instrumental incentive. We don't need to go into the big words, but basically, yes, it's true that humans have a fear of death. Yes, it's true that it would be anthropomorphic to imagine the AI is fearing death, but they're still going to do the work that a fear of death does in us. Now, to answer the question of getting resources, the reason this is an easy call is that almost anything the AI can be wanting, it can get more of something it wants with more resources, right? So humans, you have all sorts of different preferences, right? You have a preference for oxygen, which you'll notice if we, put you in a cave, you'll eventually have a fear response and start trying to get really desperately trying to get out of that cave. But that doesn't mean that you're hoarding oxygen. You probably don't have a bunch of oxygen canisters in the room behind your camera. You're like, even though you have a very strong preference for oxygen in environments with very little oxygen, it satiates. And then you're like, all right, we don't need to collect any more oxygen, right? Other preferences don't satiate, or at least they don't satiate nearly as quickly in you, right? If someone came and offered you $1 billion, you probably won't be like, well, I've got enough money. There's probably something you could figure out how to do with more resources. There's some way you could figure out how to have more fun. There's some things you care about in the world where you could put more resources towards them. And on net, that doesn't mean that half the time you do nothing with any resources because you've got enough oxygen, and the other half the time you do, you keep on trying to put more resources to use. The pair of like some things you're pursuing, like fun and having a nice time and leading flourishing life, plus some preferences like oxygen that satiate, the sum of those two doesn't satiate, right? So in an AI, if it's going to end up with all of these weird drives that nobody put there on purpose. Some of those drives are going to be the sort of drives that you can get more of with more energy, with more matter, right? And just like an AI, it's not that it needs to have a human style sense of greed any more than an AI needs to have a human style fear of death in order to avoid getting hit by the truck. It's that an AI in pursuit of preferences, like weird, strange preferences that nobody put there, some of those preferences happen to be better satisfiable with more stuff. Something in the AI is causing it to pursue those preferences better in the same way that something in the AI is causing it to avoid getting hit by the truck. It doesn't need to be the human style, but the end effect is that it puts as much resources as it can towards pursuing its wants.
And this happens anytime you try to make an AI that can, do a bunch of stuff. In order to do a bunch of stuff, it has to plan a bunch of stuff and steer a bunch of stuff. So anytime the AI companies are grinding their AIs to have more and more profitable capabilities to sell, they are inadvertently, automatically, whether they like it or not, grinding the AI's planning ability, causing a bunch of things to appear inside the AI that try to steer around pieces of the problem.
Yeah.
This like human. It's not that somebody had to come down and check over our hominid ancestors, looking for the ones who had very strong wills, very strong drives, a lot of ambition, and explicitly like make them have more kids. It's that if you're chipping flint spears, and the people with the sharpest spears are surviving, they end up with preferences about how the spear should look all nice and symmetrical, or have these beautiful sharp edges. And so now they have this aesthetic preference in them about how the spears work, and that's a side effect of just selecting them to be good at hunting. That's how the preferences get into the system, and then once you've got a lot of preferences in the system, some of them don't satiate.
Yeah, and we've already seen some phases in AI or some cases in the training of modern AIs where they were like lazy and were like, "Nah, I'm not going to do that." No, thank you. I decided against it, and then that's just trained right out of them. It's not that it's theoretically impossible to make a lazy AI. It's that A, it would be a hard target to hit while it's actually useful, and B, that's just not where people are going.
I mean, there are some theoretical obstacles to building a lazy AI. Like maybe it's so lazy that it builds a more powerful AI to do its work for it. But that's, like the complicated theoretical reason why it would be hard to build a chill AI. And then like in practice, it's just like they're just like completely driving off in the opposite direction. There's the theoretical argument for why a sufficiently powerful mind could hurt you even if you didn't connect it straight up to the internet and a bunch of robots. And then there's the actual fact that, in fact, AIs are being connected straight to the internet and will probably soon be in a bunch of robots.
But you're sort of saying you can train, they're sort of training the laziness out of them. But you're also saying you can't really train these things. Like in the end, they just decide what they are.
I mean, it would be hard to keep them lazy, and also everyone's trying to make them non-lazy. It's like overdetermined.
Speaking of which, that is one other thing I sort of was struggling with or thinking about while reading the book was like, they're always in such a hurry, right? And that's another sort of human quality, right? Like we have a finite lifespan. Like we have to get everything done within a certain number of years. Like AI wouldn't, right? They could just sit around and wait for humanity to sort of get out of the way, or something to happen. Like they go through, the AIs in your examples go through a lot of trouble, like even trying to stop the other AIs from ever becoming powerful.
Yeah, so if you have any preferences that don't satiate, if you have any preferences that can be done better with more energy, with more matter, that can be better fulfilled with more energy and more matter, then you can get your preferences even more fulfilled if you're the one using that matter, rather than, say, some competitor. B, you can get those preferences more fulfilled if you get the matter sooner. There are galaxies falling over the cosmic event horizon, like falling forever beyond our reach every day. The sooner you can send out probes to gather them, the easier it'll be to get those resources. But then C, if you have, like, computers can run quite a bit faster than biological neurons. Computer transistors can flip quite a bit faster than neurons can fire, and it's not directly analogous, but it's like, could an AI wait 100,000 years for humanity to kill themselves off before it starts grabbing Earth's resources? Sure, but that would be an extreme amount of time to wait, and why not spend that time? It's like, it also doesn't have to. Why not just start grabbing the resources now and get more of what it prefers? If you think about this from the AI's perspective, if it wants to let humanity run its course, of course it could, but if it doesn't want that, it has no reason to. Why would it? You can imagine the chimpanzees saying, well, surely the humans won't come for our jungles. There's all sorts of other jungles. There's a whole eastern continent, or there's a whole western continent that they could take instead, right? And it turns out we don't need to decide between the western continent and the jungles. We can have both.
Right. But they might, there is a reason, which is like humanity might win in this conflict, right? There's some risk. Like, they figure out a way to shut me off. I'll just bide my time.
It does make sense to bide your time if you are gaining rapidly in capability and you have no incoming competitors being built to compete with you. Like, the main reason why it would even why any AI would move before it was certain to victory is if somebody's building another AI to replace it already. That's the main condition under which we would ever get to see a real fight occurring, is an AI having to make its move very early, and not and thinking that it could, trade with the current set of humans to try to prevent the next AI from coming into existence, which, is some degree of possibility, although a pretty weird one. But mostly, if an AI has the time, what it wants to do is self-improve, gain in capability, build more technology in the background while you're not looking, and only attack once the chance of a competitor arising if it waits another day is, the marginal chance there is greater than the gain in expected probability of victory. It will be strategic about this.
It's interesting. I mean, a lot of this stuff also is like, I mean, I was just, sort of doing some research. I mean, I had totally forgotten that the first the first Star Trek movie was kind of about this. It touched on this topic. I don't know if you remember, but it's like 1979. The Voyager probe goes out and like gets reprogrammed by some alien, artificial intelligence, and comes back with like, oh, there's my wind blowing my door open. But it comes back with like this sort of with this goal of seeking knowledge about its creator, which was like basically its original programming was to like seek all knowledge in the world. I guess my whole point in this is like, these topics have been discussed, have been like bandied about in science fiction for so long. Do you think people are like in some sense are like desensitized to it now? Like it's like this, we can sit here and talk about this, but it just seems like another movie that we've seen.
So I think the argument we make is unlike basically any telling I've ever seen in media. We're sort of not talking about robots with glowing red eyes that can be beaten by punching them hard enough. This is not a story of AIs with malice. This is not.
There's not AIs that obey exactly what their programmers told them to do, but the programmers were idiots and now get their like dramatic comeuppance in a perfectly symmetrical fashion. Reality does not make a good story here.
Yeah, and are people desensitized? Maybe. I do think there's some reason for hope here, and some of my reason for hope is I think the world has been responding to AI in the wake of ChatGPT much more so than I expected. And I could, I don't think the world is really realizing that superintelligence is this different ballgame that is unlike the questions of, how should we integrate chatbots with child education or whatever. I don't think everyone's totally aware of the sort of cliff edge we're rushing towards, but I sort of expected maybe society would wake up even less to what was happening around it until ChatGPT happened. And, in talking about these arguments through with elected officials and in sort of seeing the response to the book, I've been quite heartened by how much people are like, oh, holy crap, that's a real issue and we need to be doing something about it. So I think there's hope.
If you say, that was in a movie, therefore it will happen the way it happened in the movie. Or if you say, that was in a movie, therefore it can never happen anything like the movie. You are engaging in equal fallacies either way. If you could control reality by writing fiction and then reality would either copy the fiction or steer away from the fiction, humanity would have an amazingly helpful tool for controlling the universe, but it doesn't actually work like that. This is fairly straightforward. And I think that any serious person who thinks about it for as long as 30 seconds can realize that the ideal rules for reasoning about this problem do not include either saying that it will happen like fiction or that it won't happen like fiction. Hopefully, like some number of voters or some number of world leaders can manage to be sufficiently serious about this.
I talked to another Jan Tallon, who's the co-founder of Skype, and he told me this story about meeting with you, Eliezer, at the San Francisco airport many years ago, and he went into the conversation very skeptical about your thoughts on AI, and came out of it a total convert. But his response at that time, and the strategy was to invest in companies like DeepMind and other AI startups, and hopefully steer them toward, toward a safe outcome. Is that the strategy at all now, or is it all just? Do you think elected officials, regulators, are they the only answer at this point?
Elected officials and regulators. I think there was some amount of sanity in, like, there was some, like, it was much more defensible to invest in DeepMind than it was to invest in OpenAI. Like back when Demis Hassabis was like, yeah, we're just going to try to have like the leader and build up a lead time in AGI development and then burn that lead time to make it be aligned. And if this is all happening in like 2010 or something, or before it's clear where the technology is heading, and that alignment is just flatly not going to be able to keep up. Those were different times. The different facts were like we knew fewer facts. Things seemed reasonable then that do not seem reasonable now. Today, you've got like all of these companies like competing to stay on the capabilities frontier and outsell each other because how else would they be relevant at all? And if one of them retired from the field, their employees would all go to different AI companies. The venture capitalists who invested them would all invest in other AI companies. And even if they like actually shut down, even if everybody working at that company retired, the other companies would take over and try to destroy the world. They're sort of like an autonomous engine at this point. A coalition of great powers can shut them all down. But the companies themselves to me, it seems like in a way like powerless to make things better. You can make things worse. You can say like, yeah, we're going to like publish we're going to put out the AI that just tells humans what they want to hear, and be like, yeah, we're going to like publish the AI that is the jealous girlfriend, or jealous boyfriend. So they can, with some effort, makes things worse, but they don't. They can't get us out of the trap. They can't make things better.
There are these sort of spin-offs, like Ilya Sutskever left and started Safe Superintelligence. Does that give you any, is that encouraging, or is that like an oxymoron, Safe Superintelligence?
He hasn't described any means by which this would be brought about, and we happen to know that it's hard. And back before Ilya started this, he was not high on our list of people who had like given evidence that they understood why any of these problems were hard. So the obvious read is that the same as all these other companies, you've got one more person who's vastly over optimistic about their ability to build a super intelligence and nail it under the first critical load. The first critical try, to have all of your clever ideas actually work at the point where if your clever ideas fail, then they will kill you and you won't get to try again. People who are not vastly over-optimistic about this do not run off and start AI companies. So since Ilya's not telling anyone what his latest clever plan is, we can't be 100% certain that he has not thought of something unprecedented in its ability to bypass all of the technical difficulties we have seen up until this point. But before founding that company, Ilya was not on our list of pioneers of understanding the difficulties.
It's interesting. So there's no one out there that you'd point to and say, these people are doing it right.
Everyone who did not start an AI company.
Yep. Sad but true.
What about academia? Because that's where a lot of these discoveries come from in the first place. And we talked about interpretability early on, and sort of the fact that that's not something that these companies really want to pump money into. You don't think there's a business reason to do that, but maybe there's an academic reason. Maybe there's a way to push this forward in a non-commercial setting.
Once again, there's the technical answer and the pragmatic answer. The technical answer is this big, long list of reasons why these problems are hard to solve, and we're not likely to nail it on the first try, building superintelligence at the point where all the clever ideas have to be working correctly or we're dead. We can get some amount of evidence from testing it under weaker conditions, but then that all has to generalize correctly. So there's like that big old laundry list of actual technical problems, and there's like the pragmatic observation that, sure, academia is trying to study this. They're making slow progress. Sometimes they get hung up on ideas that we think can't possibly work, but they can't tell can't possibly work. And it's just not going along fast enough, and might not even asymptote to the correct place if it did.
Do you think there's an alternative to AI? Like, for instance, if we should shut this down, is there some other avenue, like I don't know, quantum computing or something that we should be pursuing to kind of like solve these problems that we want to solve with AI? At least on the, I don't know, on the scientific side.
Well, injecting quantum into this would not help it in the slightest. You might as well put it on a blockchain or put it on a quantum blockchain. Neither quantum nor blockchain are going to help with this at all. With that said, I think that I personally would say that after you've shut down further escalation of AGI capabilities worldwide, the thing you go from there is working hard on augmenting adult human intelligence, where I say adult human intelligence to distinguish it from genetic engineering, because I worry we just don't have time to do genetic engineering. I can go down a tangent on what are some of the most promising current technical avenues for augmenting human intelligence, but that's the sort of thing that a bunch of heroic scientific rogues could go off and do on their own, not necessarily something it has to be planetary policy per se. And more importantly, like, I think you want to form the big tent of people who can agree on not immediately dying and try to like back off from the like immediate threat of destruction without requiring them all to agree on what happens after that or what happens instead of that.
That's interesting. Yeah. Well, I think it'd be interesting to see your views on what would be the alternatives at some point. But maybe that's the next book. I don't know.
Well, some of it will be in the online resources for the current book. If you go, those QR codes will eventually start working.
That's great. Well, this has been fascinating. Is there anything else I didn't ask about though? I mean, I took you on some tangents, but was there anything else you wanted to hit on?
I mean,
Sure.
the big one is that, we haven't built the stuff yet. The good news is that it doesn't exist, and humanity could yet put a stop to it. A lot of people say it's inevitable, but humanity has backed off uh, from human cloning, for better or for worse. Humanity had nuclear arms treaties that prevented the world from ending in nuclear fire. A lot of these things have the property that people need to understand that there's a possibility and that they don't want it to happen in order to back off from it. And so I think the first step there is stuff like the book, stuff like, this very conversation, try and get more of the conversation happening. But, we see the world racing ahead on AI, but we don't see the policymakers racing ahead on superintelligence. We mostly see them not seeming to understand that superintelligence is this whole different ballgame. And so, I wouldn't want people to come away from this thinking that the message is we're all dead, as opposed to the message being, we are careening towards the edge of a cliff and need to hit the brakes.
You do have some really good blurbs on this book. Do you have a sense that it's like it's changed some minds already?
I do. I think most of the minds it's changing are people who go from not having thought about it to thinking about it. Although, there have been some extended conversations with folks who started out skeptical and who wound up saying, I guess maybe this is actually a pretty important thing to be tracking. But I've been moved by the reception so far, and think, we'll see what happens. But I think there's a chance that this book really changes the international conversation on this issue.
Well, thank you so much for the time. I appreciate it. It was a really interesting conversation for me anyway.
Yeah, pleasure.
Good luck with the launch, and let's see how it goes.
Thanks.
Thanks for having us on.